देखते हैं व्हाट इज़ द स्ट्रक्चर ऑफ एटमॉस्फेयर. ओके, सो वी नो दैट देयर आर डिफरेंट काइंड्स ऑफ लेयर, बेस्ड ऑन टेम्परेचर, डिफरेंट काइंड्स ऑफ लेयर based on temperature के basis पे we have different layers in the atmosphere. Okay, so starting from the bottom, what do we have troposphere, in which we are living, we are breathing air. Okay, above that we have stratosphere, above that we have mesosphere, and above that we have thermosphere, and above that we have exosphere finally. Okay, so these all we will see later, but let's see, there are two major divisions in the atmosphere based on the amount of gases that are there, based on the composition are there, based on the density of airs are there. So first layer is called the homosphere. Homosphere is further divided into three layers. First one is troposphere, second is stratosphere, third one is mesosphere. Okay, and in the heterosphere we have two layers. What is that? First one is thermosphere, last one is exosphere. Okay, so what is the difference between this homosphere and why have they been segregated like this? Okay, so now let's look at some of the basic facts. Now, homosphere, from the surface of earth, it extends up to 80 kilometer. In 80 kilometer, like 80 kilometer we have three layers. Okay, well, as I have told you, 80 kilometer. Now heterosphere extends beyond 80 kilometer, 80 to outer space it extends up to. Okay, now in this homosphere gases are uniformly mixed. Okay, what does that mean? Like suppose if you take this portion of air, or suppose this you take small portion of air, here the amount of nitrogen present will be 78%. Okay, suppose you took 100 grams of gas. Okay, so here the amount of nitrogen is going to be 78 gram, 21 gram of oxygen, and rest of the gases in 1 gram. Okay, now suppose you took here 10 gram of gases, here you will have 7.8 gram of nitrogen. Okay, 2.1 gram of oxygen and 0.1 gram of other gases. This is what is mean. The proportion is fixed. Okay, there is no variation in the proportion of gases. Okay, now let's look, and in here we have different layers. In the heterosphere we will have different layers, follow based on the gases are segregated based on their molecular weight. Like suppose the bottommost layer will be of nitrogen, above that it will be of oxygen. Okay, only nitrogen will be found in this circle, only nitrogen. Only oxygen will be found in this circle, only helium will be found in this, and finally hydrogen will be found in the outer circle. This is what is meant by different layers. Okay, so we know that. Now let's look at the third differentiation. It is the molecular form. The gases, they are in molecular form. Hydrogen, oxygen, okay, nitrogen, they are in molecular, like there are this, like this, oxygen double bond, hydrogen double single bond. Okay, like this, they are in molecular form. That allows the exchange of energy to be very easy. Now here it is in atomic form. In heterosphere it is in atomic form. Suppose we have nitrogen lower layer. Okay, now they have the capability to break into nitrogen separated from nitrogen. Oxygen you may get into like this, O2 minus. Okay, so here what are we having? Here we are having the molecular form. They are now in atomic form. Separate atoms, they exist in separate atoms. Okay, now let's look at the water vapor and dust particle concentration is very high. Of course, as I have told you, most of the dust particles and water vapor, they are confined within homosphere, particularly troposphere only. You may find some amount in higher layer also, but they will be confined to homosphere only. And finally heterosphere we have negligible amount of such kind of material in the heterosphere. Now let's look at the homosphere. Now we will see each of these layer in detail. पहला layer है troposphere. Troposphere में क्या होता है ना, troposphere जैसे ये ट्रोपोस्फेयर दिखाया मैंने, ठीक है। तो सबसे इम्पॉर्टेंट लेयर की होता है, मोस्ट इम्पॉर्टेंट लेयर की होता है, क्योंकि ये सारे इम्पॉर्टेंट गैसेस हाई डेंसिटी में इसी में है। ऑक्सीजन ले लो, कार्बन डाइऑक्साइड ले लो, ठीक है। और जितने भी इंपॉर्टेंट गैसेस है, जो डस्ट, जो वेदर फिनोमेना हेल्प करते हैं ना, दे आर ऑल्सो कन्फाइंड इन दिस ओनली। Okay, so this becomes the most important layer of the atmosphere. उसके बाद क्या है, ऑल वेदर पे ना टेम्परेचर डिक्रीजेज विद हाइट ना. एक कंसेप्ट देखते हैं, जैसे सोर्स ऑफ हीट ऑफ द अर्थ एटमॉस्फेयर इज़ नॉट सन, इट इज़ द टेरेस्ट्रियल रेडिएशन. ये हम लोग बाद में देखेंगे एल्बिडो या फिर हर इंस्टॉलेशन वाला चैप्टर में. तो जो सन से रे आ रही है ना, इससे एटमॉस्फेयर हीट नहीं हो रहा है, इट इज़ द आउटगोइंग टेरेस्ट्रियल रेडिएशन दैट इज़ हीटिंग अप द एटमॉस्फेयर. सो जितना दूर टेम्परेचर, जितना लेयर ऊपर होगा उतना ही हीट कम होगा. तो मैक्सिमम हीट विल बी एट द बॉटम ऑफ द सर्फेस, और आप जितना दूर जाओगे इस हीट सोर्स से द टेम्परेचर विल डिक्रीज. तो इसी को बोलते हैं नॉर्मल लैब सेट. नॉर्मल लैब सेट एक हाइपोथेटिकल, एक इंपॉर्टेंट चीज़ है, इट इज़ एन हाइपोथेटिकल, it is an hypothetical concept that says that with 1 kilometer temperature decreases by 6.5 degree per centigrade, but it is for ideal state. Okay, in reality what we have is environmental lapse rate, which means depending upon the surface, depending upon the season, the rate of cooling down is not uniform, like we have assumed that 6.5 degrees centigrade. So this point should be noted. Okay, so normal lapse rate says, what is that normal lapse rate? The temperature decreases by 6.5 degree per centigrade per kilometer, or it is 1 degree per 165 kilometer as per the NCERT. Okay, so what we are saying, zone of turbulence due to high amount of water vapor and convection. So we know there is water vapor. Okay, water vapor, so there is constant convection is going on. Okay, because of the turbulence is created, disturbance, instability is there, because water is getting evaporated. The air at the bottom in contact with the surface, they gain heat, they rise up and they expand. Okay, suppose let me show you again. So now suppose this is the surface, okay, and this is troposphere edge. Okay, now the air in contact with the surface, they will gain heat. Okay, now they will start expanding. Okay, in that process the air is uplifted. Okay, this upliftment of air, because of the exchange of heat from the ground surface, it is called convection. Okay, which creates turbulence. Okay, now height varies across equator and poles. Okay, now this is something that you should know. If this is earth, ठीक है, तो equator पे we know the maximum insolation is along the tropics. ठीक है, because of that the air will rise, they will expand more compared to the poles, because here the light is at slant angle. Okay, so here the air will rise more compared to the poles. Hence the height at which the height of troposphere at the equator, it is more, it is around 18 kilometer, and it is only 8 kilometer poles पे. ठीक है, now if you take the average, 18 plus 8 by 2, it is 13 kilometer is the average height of the troposphere. It is because of the strong convectional currents. The height is more at the equator because of the strong convectional currents. This is one prelims pointer. Okay, now suppose stratosphere. Now suppose before moving to the stratosphere, there is one layer called tropopause. Okay, now one thing to know, troposphere is also known by different layers. It is also called friction layer because it is in constant contact with the surface, so there is constant friction going on. It is also called zone of turbulence, as I have told you why it is called zone of turbulence, because of the strong convection current. Okay, now suppose the air, there is one lid. This is one lid, you know, that prevents something from going out. Lid, tropopause, that lid is tropopause. That means the water, whatever water will rise, whatever convection will rise, they won't go to stratosphere, they will just graze the surface of tropopause and then descend somewhere. Okay, so nothing escapes tropopause. It acts as like a lid. ठीक है, आई होप थिंग्स आर क्लियर यहाँ तक. ठीक है, तो नाउ लेट्स गो टू ट्रोपोपॉज. स्ट्रेटोस्फेयर में क्या होता है ना, स्ट्रेटोस्फेयर, here you have seen that temperature is decreasing, but in the stratosphere it contains ozone, O3. Okay, now O3, you must, if you know the structure, this is the structure of O3. Okay, now when high energy UV light comes now, it breaks one oxygen atom. So what we are now left with, O2 plus O free radical. Now this is very reactive. It will go again and then react with some free oxygen. Okay, now then again it will form, then again UV light will attack, फिर से ये टूट जाएगा O2 और O में. ठीक है, तो this continuous process goes on. This process is known as Chapman cycle. Okay, this is and in this reaction only, absorption of UV, breaking, this reaction increases the temperature of stratosphere. So here what we see, with height increase in height, the temperature here increases. So it is the reverse of normal lapse rate. Okay, I hope things are clear till now here. Okay, so here the gases are arranged in no convection at all. Here we have seen that convection is confined to troposphere only. Okay, and they diverge along the boundary of tropopause, and in some cases few gases can escape. In few cases gases can, and they can form clouds here. Okay, can you name some clouds? They are mother of pearl, nacreous cloud, etc. Okay, few clouds can form here, but it is the most ideal place to fly your aircrafts, because there is no convection, no turbulence here, so the air can fly very easily without consuming ज़्यादा petrol fuel, ज़्यादा consumption के बगैर ही it can travel easily here. Okay, so this is something that I wanted to discuss about stratosphere. So like tropopause, here also we have a lid called stratopause. Okay, crossing the stratopause, what happens? The normal lapse rate starts again. Okay, so the temperature again starts to decrease at the rate of 6.5 degree centigrade per kilometer. Okay, so the lowest temperature in the atmosphere is recorded here, that is around minus 100 degrees centigrade at 80 kilometer. Okay, so we have seen all the three layers of homosphere we have seen up to mesosphere. Mesosphere is mostly a transition layer between the outer division and the inner division. It is mostly a transition layer. Okay, now after this there are some clouds in mesosphere also. They are known as noctilucent cloud. Okay, in depth we do not need to know क्यों ये कैसे form होता है, just know as a prelims fact there is, like most of the clouds they are formed in the troposphere, few formed along the stratosphere, like I have meant mother of pearl, nacreous. Okay, उसके बाद we have one in mesosphere, that is noctilucent cloud. For prelims fact you can know all this. Okay, now let's move to the heterosphere division. Okay, now here we have mostly one extra layers come ionosphere, that is a part of nothing but thermosphere only. Okay, so let's go to thermosphere. Here we can see that is again the reversal of normal lapse. So the temperature again starts rising. But why is that? But first we need to know that its height extends from 80 kilometer, that is the boundary of mesopause, up to 500 to 700 kilometer. Temperature here reaches a very high because in this region the high energy solar radiation, they are absorbed by the gases present. Okay, high energy electromagnetic is absorbed. Gases are in different layers, like I told you, nitrogen, there is separate layer for oxygen, there is separate layer for helium, there is separate layer for hydrogen. Okay, the gases are arranged in different layers here. But one thing, even though the temperature बहुत ज़्यादा है इसका, but if I place you in a thermosphere, like suppose if I place you in thermosphere, you do not feel the heat. What is the reason? Because here the density of gases are very rarefied, like the gases are very rarefied in atomic form. First they are in atomic form. Okay, they are very far apart. Okay, though, and one more thing, like suppose if I can show you with a diagram, if this is earth, okay, and this is your the area extent of thermosphere. Okay, now, and suppose this is troposphere. Heat is observed but the area is less, so energy intensity becomes high. Okay, energy intensity is energy received divided by area. Okay, since the area is less, we feel more heat in the troposphere only. But if you see the extent, like what is the extent of troposphere, it is only average at 13 kilometers. Entire energy is distributed along a sphere of 13 kilometer compared to thermosphere, which is having an extent of around 570 kilometer. I think 570 is right, yes, 570 kilometer, and high energy. So energy is very high, energy is very high, okay, and area is also very high. So the entire resultant energy intensity becomes a bit lower than troposphere. That is why if I place you outside if I place in thermosphere, you do not feel the heat because of three reasons. First, second, third. First, energy intensity is not that high. Second, atomic form of gases rarefied, not density of gases is very low. Okay, these things I wanted to discuss with you. Now there is one important layer, and we have seen one prelims question on this also, the concept of ionosphere. Okay, so here, due to the high energy coming from the insolation, the gases present, they convert themselves into ions. Gases, they convert in itself into ions. And what are ions? Ions is when any element it gains electron, or when loses electron, it converts itself into ion. They are very highly energetic charged particles, and they help in the ionosphere, they help in long wave radio communication. Okay, now here what we see, ions capable of reflecting radio waves, radio communication, they are very useful in. This is all we have. Now we know that there are different layers, in D layer, E layer, F layer, different kinds of layers are there, where D and E layers, they disappear at night. Okay, so in that detail we do not have to go, but we just have to know that what is ionosphere, where it is placed, and what is the function of it. Okay, what is the function of it, all I have told you. Okay, now in the end, let's go to the final layer, exosphere. Okay, now this merges with the atmosphere, the boundary of exosphere, it merges with the space, outer space. Okay, the gases here are in atomic form. Okay, and they lose electrons and gain electrons, like I have told you, and roaming gets in the bands called a Charles Sun Van Allen radiation belt. Okay, now let's see, if this is Earth, suppose this is where the thermosphere ends, and after that exosphere starts. Okay, the exosphere mein, there are gases in atomic form. Okay, here what happens, the ions are there, they arrange themselves in two bands. Okay, two bands, they are known as Van Allen radiation belt, one at 3000 kilometer and another at 16,000 kilometer. Okay, so these two bands are called Van Allen radiation belt, where you see auroras are formed in these two bands only. Auroras formed. Okay, this is all you have to know for a quick revision to all the, like till now we have done the differences between weather and climate. Okay, the basic composition of what is atmosphere, what is the basic composition of atmosphere, what different gases are, what are their functions in the atmosphere, what is the function of dust particle, what is the function of water vapor. Okay, so we see that 99% of the gases that do not have any role in the atmosphere. More important role is played by gases like carbon dioxide, H2O, dust particles, and how they vary on globe. Okay, so here then we saw what is the structure of atmosphere, what is homosphere, what is heterosphere, what are the layers that come in homosphere, and what are the layers that come under heterosphere. Okay, we differentiated between the two. Okay, now we saw the properties of different gases, different layers, and what is normal lapse rate, what is environmental lapse rate. Right, till now we have done here.